Hello, and welcome back to another video. Today we're going to be doing 703 Kth Largest Element in a Stream. So we want to have a class to find the Kth Largest Element in a stream, which is Kth Largest Element in sorted order, not the distinct element. So we need to implement this class where we're given, let's see. Object, we initialize it with an object with integer k and the stream of integers nums, and then we want to add values to it, and you want to find the kth largest element. Okay, that makes sense. So let's say, okay, for example, we take a look and we initialize it with a new kth largest data structure where we have 3, and then we want to figure out what the third largest number is in this array always. So we add 3, and then we should return 4 because that's the third largest one. And then same thing with 5. We have 5, add 10, still the third largest element, 9 third largest element, 4 third largest element, etc, etc. Okay, well, just taking a look at this, because we're trying to find something that's the kth largest element and we want it to be optimal, I'm thinking of using a heap for this, because a heap is an efficient data structure which allows you to grab elements, like the minimum, like the smallest element and the largest element. So we'll have that. So another thing we want to consider is how large do we want the heap to be? Well, because we want to only keep the third largest elements, what we need to do is we need to have it so that the heap is of size k. Now, just to kind of test this out, imagine we initialize a heap. We have 4, 5, 8, and then 2, and then we want it to be the third largest element, so we only keep the top 3 biggest, top kth largest. So we go ahead and remove this one, 2, so we have this one, and then next time we want it to return with the kth largest element as you add it, let's say like we want to add like a number 12, we can go ahead and add it here, and then what it's going to do is it's going to boot out the third largest element always, which is going to be 4. So we remove this, we pop this from the heap, and then we add 12. Now, in order to pop it from the heap, we need to go ahead and grab it. And grabbing that operation is needs to be it doesn't need to be, but it would be better if it's an O of 1 operation. And so we can use a min heap for this, because we'll always have access to the actual heap, the top of the heap, the minimum of the heap itself. So if that makes sense, I'm going to go ahead and begin implementing it with a min heap. So first things first, we can initialize the heap, or I guess the min heap, to be equal to I think it's been a little while. Let me search up the syntax for Python heap. Here we go. Okay, well, we have to initialize a heap, you can do heap pop, heap push, heapify. Okay, that makes sense. And then there we go. Okay. Okay, that makes sense. So heap q, we'll import heap q, and then we can heapify the array as we do this. And then heap push, heap pop. Okay, those are the elements that we need. And then heapify. Yeah. Okay, sounds good. So I guess first of all then, what we're going to want to do is we're going to want to initialize the min heap with the heap q. So import heap q. Yeah. And then from here, what we want to do is we want to figure out, we want to instantiate this. So we want the min heap to be the heap q dot heapify. We want to heapify, like it says, the nums array. But while we do this, we only want to keep the third largest ones. So actually, while we initialize this, instead of doing it like this, we can have a heap, right? Self.min heap is going to be equal to this, and then yeah, that's how you would instantiate it, if I'm correct. Okay, so next thing we can do is we can do for v in nums, we can do min heap q dot heapify the min heap self.min heap as well as the current number, and we only want to do this if the length of it is less than k. So if it is, if let's say self.min heap, if the length of it is equal to 3 is equal to or 3 or k, then we want it to stop. So then we want to do a return really quickly, and then that's going to be our initialization over here. Okay. For the actual adding operation itself, what we're going to want to do is we're going to want to append the current val to the stream. So we want to heap push, heap q dot heap push, and then just take a look at the syntax again. Heap push. Yeah, you're given the heap in the item, so we want to have the self dot min heap, and then we also want to have the actual element itself. So we'll do heap push val, and then as we push this, we actually want to pop the smallest element from the min heap before we do that, because that's going to be the kth largest element. So we want to have a return value, so kth largest, which is going to be equal to heap q dot heap pop self dot min heap and val, and then we push this, and then we can return that at the very end. Kth largest. So just taking a look at this again, we'll imagine it as it goes along. So we add all of these numbers 4, 5, 8, 2, right? So 4, 5, 8, 2. Well, oops. Oh, actually, another thing we actually have to consider is we don't want to. We don't want the actual, as we're adding the value to the min heap, well, what this is going to do is as we're adding it, it's only going to grab these 3 and not go for the rest of them. But we actually wanted to account for all of it before considering the length. So actually for this one, oh, this is the wrong syntax. You can't heapify it for like this. This should be heap push. What you actually want to do is first you want to heapify all of the values, and then what you want to do next after this is you want to do for like while length of heapify self dot min heap is less than the heap q. Well, it was less than k, less than or equal to k, or less than k. Actually, no, it has to be greater than k. We want to keep popping it, so we want to do heap q dot heap pop self dot min heap val, and then we want to keep doing that until it reaches its element over here, like until it reaches its end. So 4, 5, 8, 2, and we want to keep popping it until we have the kth largest. So we want to pop this one, etc., until it's equal to 3. Okay, now next thing we want to do is we're going to want to make sure that this happens for the adding one as well. Well, actually, because the initialization is set to k of the length of the min heap, and adding it always removes one and then adds one. It'll keep staying constantly at the kth length, so we don't need to actually do anything for the adding one. So if you go ahead and just quickly run this, yeah, just gonna make sure there's nothing that we're missing. Okay. Oh, sorry. Actually, want to do this. Oh, and we want to heapify the nums array. Oh, right. We should probably do this actually. Self.min heap is equal to heapify nums. And we have an object of none type. Let's take a look at heapify again. Yeah, transform listen to heap in place in linear time. Oh, it does it in place. So we'll actually have that set to nums. And then we want to heap, yeah, heap q.heapify nums. We'll do this first, actually. And then we'll set that to the min heap, and then we'll check for the length. Oh, yeah, we want to pop. Kth largest element has no attribute self.min heap. Oh, yeah, same thing again. We want a heap pop. I definitely need to check for more typos. Okay, here we go. Our output four, 5, 5, 8. Where it's supposed to be 5, 5, 8, 8. Oh, I see. Actually, we want this to only be done if the min heap, if it exceeds the length of the min heap. So we do if length of self.min heap is greater than the val, what we want to do is then we heap pop it. Heap q.heap pop self.min heap. Otherwise, we just want to actually return, oh sorry, this is k. Otherwise, you just want to return the self.min heap 0th element again. So if you run that, well, like the top of the index, or top of the the min heap. Oh, we should probably also set this as a value. Self.k is equal to k. Yeah. Run this again. Okay, there we go. And we quickly submit. Nice. The time complexity of it is going to be O of n for the initialization, because the nature of the heapify method is it's linearly going through the list before and putting it into the array. The adding one is also going to be, I believe it's going to be O of 1, because you're just pushing the value and then popping it. So that's what makes it efficient in this case. So yeah. Well, thank you for watching.